Hi guys, Doctorbass here. Today I want to test the Supercharger Diginow units, the 3.3 kilowatt units, and I will explain why I want to make that test first, and then I will describe all the tests to you and explain the process and the data that I will collect. So in fact, I was charging my Zero at a charge station in an industrial area where normally those charge stations are giving you 208 volt instead of 240. This happened when the grid is on the three-phase circuit. So those charge stations usually in the industrial area are working on 208. And what happened with my unit, I'm not sure if you guys have different version, but my version is drawing more current to compensate on the 208, because since you have less voltage, it will ask more current to get you the same power. And that's what happened. And I just blew the circuit breaker of the charge station. I was drawing about 35 amp with two charge units. And 35 is not tolerated by the 30 amp breaker of that charge station. So I want to test at every voltage, every AC voltage, how much current the unit will draw, and then I will be able to predict how much current I will need and to select the right charge station to not have that problem anymore. So I have a setup here, you see. So I bought this Variac auto transformer, variable transformer, call it whatever you want. This one is on 240, and this is interesting because those are more rare. And you will note that this is a 9.5 amp. So I check on the data sheet and it can take more voltage. It can take up to 30 to 40 amp burst during couples of minutes. So those are pretty tough. So that's not a problem if I draw 15 amp or 16 amp like those usually require. So here's the installation. I have here my sub panel. This is one is a 240, but I don't have an extension for that kind of plug, so I have my adapter here. This is a 120, but I know, so that's not a problem. It's me that use it. And that kind of, you don't want to know, adapter that goes here. So this is the input. This is the 240 input, and this is the variable output. So that output goes onto a splitter. This is a splitter that I made to connect multiple of those units. I have a big plug here and 4 smaller plug like that. So you will notice that there's a coil here. That's to measure the current, and that's one of the output that I use only to collect the voltage. And the current sensing goes through these little low voltage wires, because that's a coil, and it goes to that meter here that I bought. It's pretty accurate. I tested that with my Fluke meter here, and it's about within less than 1%. So that won't measure power, voltage, and amp and it displayed those simultaneously, so that's great. And now for the output. So you see, this is the AC, the variable AC from the splitter that goes inside, and then the outside, I connected that. I used those adapter here, so those are SB50, those are power pole 30, those tolerate 30 amp no problem, and up to 40 sometime. So this is my power meter. This is in fact a cycle analyst. Those are very popular meter. So I use it for measuring the output of the charger. And then that goes to another converter that goes to the zero here. And that's the interface that will communicate between the zero and the supercharger. So I have set it to the lowest current it can draw. It's at about 167 volt. So it draws about 9.5 amp, which is exactly what this one can do continuously. So I will power it. And you see. So at 166 volt, it draws 9.69 amp and 1609 watt for an output of 1530 amp. So this is great to have both at the same time. In the next video, I will make every different voltage up to from about 90 volt to 240 to show you what's the results. So that will be a very interesting test. Thanks for watching.